Hello everyone. Today I am going to discuss the last problem of Leetcode Biweekly contest 150, which is shortest matching substring. So what is the problem? We are given a string S and a pattern string P, where P consists of exactly two star characters, and the star in the P matches any sequence of zero or more characters. We have to return the shortest substring of S that matches P. Okay, so let's take one example. So let's say our string is A B C B A, and our, let's say, pattern is B star B star A. Okay, now we can match this star with a C, and we can match this star with an empty character. Okay, an empty character. Then our string will be BCBA. Okay, so shortest length will be 4. Okay, I hope you get it. Now, what are the constants? The brute force solution will be to take a recursion step I comma j. Okay, I comma j will take a recursion step I comma j, and if I equals to j, I equals to j, we will go for I plus 1 plus I plus 1 comma j plus 1. Otherwise, if I not equals to j, I not equals to j, I mean si not equals to pj, you can say. Similarly, si equals to pj or si not equals to pj, then we can check if the jth character is a star. If the jth character is a star, we can move the ith character 1 by 1 I plus 1 comma j, or we can move the we can move the okay, if the jth character is a star, we can't move anything. Okay, I have to think, right? Let me think once. So if jth character is a not a star, we'll just return 0 from here. So that's what I was missing. So there are two cases here. If si equals to pj, we'll just increment I plus 1 j plus 1, and if I not equals to j, we'll check if jth character is a star. We'll just move our I pointer by 1, because we can take star as any character. And if the jth character is not a star, we will just return 0, because from I will not be possible. So this problem, with memorization, this problem could be solvable in order of n square. So the problem is solvable in order of n square with memorization dp and with recursion. Okay, I am not going to explain that in detail, but that is solvable. Now we have to think of some better solution, because our n and m are 10 to the power 5. So order of nm is not possible, so we have to think something better. So what we can think, what my solution is, my solution approach, let me discuss that. So what we are getting from the pattern string. Let's say our pattern string will be something, some s1, some string s1, there will be a star, something, some string s2, and there will be a star, and some string s3, there will be a, so there will be three substrings s1, s2, and s3. We can partition our pattern string in three substring s1, s2, and s3. Okay, now uh, what we can do? Okay, so we'll try to match this s1 with the substring of s. Okay, we'll try to match this s1 with the substring of s. Let's say our string is abc ba ca. Okay, and our s1 is, let's say, ab. Okay, s1 is, let's say, ab. So we'll match this ab with this one. Also there is no other abs. Now let's say our s2 is bc. Okay, our s2 is, let's say, cb, or s2 is cb. So we can match this s2 with cb. Okay, now let's say our s3 is ca. Okay, let's say our s3 is ca. So we can match this ca with s3. Okay, now there is no other matches. So we have matched s1 with this ab, s2 with this cb, and s3 with this ca. So we'll now try to merge the strings. Okay, because let's say we have matched it with something with s1, and there are many characters between the cb, and there are many characters and between the ca. So we can take the entire string, we can take the entire stream as this substring will match with the pattern, because these characters, these many characters will match with a star, and this match many characters will match with a star. Okay, this will be matching with a star, and this AB will match with S1, and this CB will match with S2, and this CA will match with S3. Now uh, there are two parts of the problem. First, how we are getting the matches. Okay, that is one part of the problem. we will be getting matches for both s1, s2 and s3. We'll get the matches for both s1, s2 and s3, and after that we'll solve the problem. So I will now discuss about how will we solve the problem after we get the matches. Okay, now we'll get the matches. Let's say we'll get the indexes of matches for s1. Okay, let's call it if let's say a1. Okay, a1 will be the indexes of matches with s1. For this string, a1 will be 0 because we will start from 0 and we find a match for s1. So a1 will be 0. A2 will be the matches for the s2. Okay, the matches for the s2. Here we can start from the second index to get the matches from s2. So this will be 2. Okay, a2, and a3 will be 0 1 2 3 4 5. So a3 will be 5. Okay, now what will we do? We'll try to we'll try to iterate over all the values of the a2. Okay, we'll try to match all the values of a2. Now uh, let's say we have something like I in a2. We have something like I in a2. So we'll find the rightmost index of a1. Okay, so we'll find the leftmost index of a1 which ends here. Okay, so let's call it j, and we'll find the leftmost index of a3, that is k. Okay, now our answer will be string will be nothing but k minus j. Okay, length of the string will be k minus j. Okay, so and for finding the matches, I will not going to explain the algorithm. For finding the matches, we can use kmp algorithm. So you can, I will provide the link of the kmp algorithm for gigs for gigs and cp algorithms in the description box. You can find kmp algorithm and how we can find all the matches for a particular pattern in a string, and we'll get an array. Okay, you will get an array. Mm, that is the KMP algorithm. So from KMP, we'll first find S1, S2, and S3, and we'll pass S1, S2, and S3 to the KMP algorithm, and we'll get A1, A2, and A3. And after that, this algorithm will work, and we'll get our desired string. So let's jump onto the solution. I will discuss the time complexity there. Okay. So this part, the entire part is for KMP. This is very standard KMP, and you can find it in GFG or CP algorithms. Okay, so for KMP, we find the LPS array first, and with the LPS array of the pattern, we apply it on the string. Now here, one thing I have done is that if the pattern length is 0, we are doing that our A array will be everything from -1 to n plus 1 n. Okay, why? I will explain it later. Why we are considering that if the string s1, s2, or s3 is empty, our ai array will be -1 to n, all the values. Okay, now uh, this part is, the rest of the part is simple. Okay, now let's come to the interesting part. Here I am in the t array. I am finding s1, s2, and s3. So length of the t will be 3. Okay, now our first will be a1. We are finding the indexes of s1, and second will be a2, and third will be a3. Now what I am doing here is that I am changing this 0, the all the values in the first with the end index. Okay, we when we apply KMP algorithm, we'll get the first index of the match, start index of the match. So we'll add the length of the first, and we'll get our last index. Okay, so that's what I'm doing here. So if first size is greater than 0, we are adding 0 dot size -1. So length of s1 -1. So now change of the first will be 1. Okay, because b is the last index of 1. Okay, so mm, this part is done. Now we are initializing our answer with 1 in 9. Okay, so int max you can also take. Now we are iterating over all the values of second. Okay, now we have some value I. Okay, now we'll find what is the value in the a1 array, because we have already changed a1 to the end index. So we'll find the lower bound of I in a1. Okay, we will find lower bound of I in the a1. Now we have to take something less than this. Okay, so that's why after we get the index, we'll just decrement the value of the index. Okay, similarly we will find the value of I plus length of s2, I plus length of s2, and we'll try to find the lower bound there. Okay, we'll try to find the lower bound there. That will be v. Now if u is greater than 0, greater than equals to 0, that means u is a valid index. We have found a valid end index of s1, and we have found a valid start index of s3, then there is one case to consider here, because we will find the left and right index. So I told you that j and k will be our left and right index. J and k will be our left and right index. So here hmm, but there could be case that s1 is 0. In that case we have to ignore that j, and if s3 is length of s3 is 0, we have to ignore the k. That's why I am checking that if s1 size is greater than 0, only then I am taking first u minus t0 dot size plus 1, because our first array will be nothing but we have already changed it to the end index, and we have to find the start index of s1. Okay, that's why we are decrementing fast u minus t0 dot size plus 1. Okay, now for right index we are similarly checking if size of the s3 is greater than 0, then we are taking third p will be the start index of s3, so we are checking start index of s3 plus length of s3 minus 1. Okay, and we are taking answer as minimum of answer comma r minus l plus 1, and at the end if answer is not changed from 1 in 9, we are changing the answer back to minus 1. Okay, I'll give the link of the article of KMP and how we find the matches, start index of the matches, uh, in the description box. You can check that out. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.